This lesson is over long division of polynomial functions. Let's look at h of x equals x to the third plus 2x squared minus 5x minus 6. Now let's say we knew that this could factor, and it factored into h of x equals x plus 3 times x plus 1 times x minus 2. Now my question is, can you identify the factors? Well, since it's in factored form, yes, we can identify the factors. The factors would be x plus 3, x plus 1, and x minus 2. Now, my next question, what are the zeros? Well, looking at your first factor, what value would make x plus 3 equal to 0? Well, that would be negative 3. And what about your factor of x plus 1? What would make that equal to 0? Negative 1. And how about the last factor of x minus 2? Well, that would be 2. When a polynomial is expressed in factored form, each factor determines a 0 in the function. If we know the factors, we can find the zeros. And we do that by setting each factor equal to 0. Also, if we know the factors, we can find the polynomial. We do that by multiplying the factors together. Now let's say we're given the factors only and it asks us to find the zeros. So imagine we are only given x plus 3 times x plus 1 times x minus 2. We just said if you're given the factors, you can find the zeros. You do that by setting each factor set equal to 0, which means we have x plus 3 equals 0, x plus 1 equals 0, and x minus 2 equals 0. From here, we solve each equation. We would find x equals negative 3, x equals negative 1, and x equals 2, which means we have identified the zeros. Now what if we were given the factors only, and this time it said find the polynomial? Well, if I'm only given x plus 3 times x plus 1 times x minus 2, and it's asking for the polynomial, I need to write it as a function. The first step is to simply write it as p of x equals x plus 3 times x plus 1 times x minus 2. From here, we multiply the binomials. We start from left to right. So the first two binomials we multiply are x plus 3 times x plus 1. The result of those two binomials is x squared plus 4x plus 3. But we're not done. Now we must multiply that trinomial times that last binomial. And when you do, you will find p of x equals x to the third plus 2x squared minus 5x minus 6. And that is your polynomial. Now, to be able to factor is important, but what if something is not factorable by our current methods? Let's look at x to the third minus x squared minus 17x minus 15. Notice we cannot do the AC method of factoring. Factor by grouping would not work in this case. And since it's not a quadratic, we cannot use the quadratic formula. So what do? Well, recall, a factor is a value that can evenly divide into another value. So let's take a closer look at division. Let's go back to a world where there's just numbers and say we have no calculators. Is 12 a factor of 1,608? The only way to find out, would be to do long division. Now we have to remember the proper steps to do long division. The first thing is we see how many times can 12 go into 16. Well, what operation is that? Well, that's division. And since we're only looking at the first value, I'm going to cover it up with a Post-it so I don't get distracted. So we're saying how many times can 12 divide into 16? Well, that's one time. From here, what do we do next? We multiply. We multiply 1 times 12, which gives us 12. What do we do next? Next, we subtract. So 16 minus 12 gives us 4. Now from here, what do? Well, we bring down the next value, which means I need to move my Post-it. And now we're ready to bring down our next value. Our next value is 0. Now we do those steps all over again. We go back to divide. How many times can 12 go into 40? 3 times. Now we multiply. 3 times the 12 is 36. After we multiply, we're now ready to subtract. 40 minus 36 is 4. Move my Post-it, and we're ready to bring down our last value. Now we do the cycle again. We divide. How many times can 12 divide into 48? 4 times. Now we multiply. 4 times 12 is 48. Now we're ready to subtract. 48 minus 48, well, that's 0. Now, what does that tell us? Our original question was, is 12 a factor of the number 1608? What do you think? Well, hopefully you said yes. 12 is a factor because it evenly divides into 1608 because there's no remainder. Now there's several parts to the division, and let's identify these different parts. First, the 12 is known as the divisor. That's the number you are dividing by. The result, 134, is known as your quotient. The number we were trying to divide into, the 1608, that's known as your dividend. And then the very last number at the very end, the 0, is known as our remainder. Now think back when you were in school, elementary school. Was there a way for you to check to make sure you had the right value? Yes. And so that skill still comes into play. To see if it checks, we simply multiply the 12 times the 134, and we add any remainders, and it should equal our original value. So using the generic place values, that would mean the dividend equals the divisor times the quotient plus any remainders. Now, since we're in algebra, we like to shorten up some names. So instead of dividend, that's known as the polynomial, or p of x. The divisor is represented by d of x. Quotient is q of x, and remainder is r of x. Since we've done long division with numbers, now let's try it again, but this time with some variables. Now the question is x plus 1 a factor of the polynomial x cubed minus x squared minus 17x minus 15? So yes, we are still going to do long division. We are still going to follow the same steps of divide, multiply, subtract, bring down. In order to kind of help you keep those steps in the correct order, here's a helpful phrase. Does McDonald's sell burgers? Maybe it'll help. Okay, the first step is to divide, and if we check out the first number, Can a two-digit value, such as x plus 1, divide into a single digit, like x cubed? No. So we must move our post-it over. Now let's divide. Since we're dealing with variables, we are going to divide the leading terms, which means we will be dividing x cubed divided by x. Now x cubed divided by x gives us x squared. So we've completed the division. Now we're ready for multiplication. We are going to multiply x squared times x plus 1. Now notice that looks like the distributive property. X squared times x and x squared times 1 would give us x cubed plus x squared. So we've completed multiplication. We're ready for subtraction. Now for subtraction, notice it's minus that whole entire value, so we must use parentheses. Since there's a negative in front, it means there's going to be sign changes. So the phrase that I use is we draw the line and change the signs. From here, now we're able to do the subtraction. We look at the terms with the same exponents. X cubed minus x cubed, well, that cancels. Negative x squared minus x squared. Since they have the same signs, we add and keep the sign. So the result is negative 2x squared. Since we've done the subtraction, we're ready to bring down. So we move our post-it over, and now we bring down negative 17x. And we do the steps again. The divide means we divide our leading terms, which means we're looking at negative 2x squared divided by x. That gives us a negative 2x. So we've done the division. Now we're ready for multiplication. Multiplication will be the negative 2x times the x plus 1, which means we will need to distribute. Negative 2x times x and negative 2x times 1. Well, that gives us negative 2x squared minus 2x. Since we've done the multiplication, we're now ready for the subtraction. Now notice, the subtraction means we're going to draw the line and change all the signs since we are distributing that negative sign. So now we have a positive 2x squared and a positive 2x. Now we're ready to subtract. Negative 2x squared plus 2x squared, well, that cancels. Negative 17x plus 2x gives us negative 15x. Since we've done the subtraction, now we're ready to bring down. We bring down the negative 15 and we start again at the division. We divide our leading terms. This time it's negative 15x divided by x, which gives us negative 15. Next, we need to multiply. We multiply negative 15 times x plus 1, and we will distribute. That turns into negative 15x minus 15. Since we've multiplied, we're ready for the subtraction. Now again, subtract means draw the line, and we're going to change the signs. So now looking at the problem, we're ready to do the subtraction. Negative 15x plus 15x cancels, and negative 15 plus 15, well, that gives you 0. Since we've done the division, now it's time to answer the original question. Is x plus 1 a factor? Yes, x plus 1 is a factor because it evenly divides into x cubed minus x squared minus 17x minus 15 with no remainder. Now again, this was long division, so it still has the same 4 parts. We have the remainder, which in this case was 0, the divisor, which was x plus 1, the quotient, which was the result, in this case was x squared minus 2x minus 15, and we have the dividend, the original expression. Now, since we had variables, can we still check this? The good news? Yes. You would check it the exact same way we did earlier. You would multiply the divisor times the quotient plus the remainder, and that will equal your dividend. This whole entire process is known as long division of polynomials. Let's look at an example. Example 1, determine whether x plus 1 and x minus 3 are factors of x cubed plus 2x squared minus 5x minus 6 by using long division. So for part A, we are going to see if we can divide x plus 1 into this expression. Now remember our steps. Does McDonald's sell burgers? We start with the division. X cubed divided by x gives us x squared. Now we're ready to multiply. X squared times x plus 1 gives us x cubed plus x squared. Now we're ready to subtract. To subtract, we draw the line and change the signs. Now we're ready to actually do the subtraction. X cubed minus x cubed, well, that cancels. Next, we have 2x squared minus x squared. That gives us x squared. Since we've completed subtraction, we're now ready to bring down the next value of minus 5x, and we do the steps again. We divide the leading terms. X squared divided by x is a positive x. Now we multiply. X times x plus 1 gives us x squared plus x. Now we're ready for subtraction, so we draw the line and change the signs. X squared minus x squared cancels. Negative 5x minus x. Since they have the same signs, add and keep the sign, and we find the result to be negative 6x. Next, we bring down. The next value is negative 6, and we start back again. We divide the leading terms. Negative 6x divided by x is negative 6. Now we multiply. Negative 6 times x plus 1 is negative 6x minus 6. Time to subtract, so we draw the line and change the signs. Negative 6x plus 6x cancels, and negative 6 plus 6 gives us 0. So we've done the division, but now we need to answer the question. Is x plus 1 a factor of the expression? Yes. In this case, x plus 1 is a factor because the remainder is 0. Now let's try the second part. Now we need to see if x minus 3 can divide into that same expression. So again, we start with division. X cubed divided by x is x squared. Now we multiply. X squared times x minus 3 gives us x cubed minus 3x squared. To subtract, we draw the line and change the signs. The x cubes cancel, and 2x squared plus 3x squared gives us 5x squared. Now we bring down minus 5x and we start back again. 5x squared divided by x is positive 5x. We multiply. 5x times x minus 3 gives us 5x squared minus 15x. To subtract, we draw the line and change the signs. Notice the 5x squareds cancel, and negative 5x plus 15x gives us 10x. Next, we bring down minus 6, and we start again. 10x divided by x is positive 10. We multiply 10 times x minus 3 is 10x minus 30. To subtract, we draw the line and change the signs. Notice the 10x's cancel, and negative 6 plus 30 leaves us with 24. Now the question is x minus 3 a factor? And in this case, no. X minus 3 is not a factor since the remainder is not 0. It's not a factor because it does not evenly divide into the value. Example 2, using long division, see if x minus 2 is a factor of x cubed minus 7x plus 6. Now look at the expression x cubed minus 7x plus 6. What do you notice? Notice it's missing the x squared term. We have to include all the terms, so we must rewrite it. The rewritten form would be x cubed plus 0x squared minus 7x plus 6. So make sure you always include any missing terms. Now we're ready to do the division, so let's set it up. Guess what? This is your try it problem. Hopefully you found the quotient or the result to be x squared plus 2x minus 3. Now, the question is x minus 2 a factor? Yes, x minus 2 is a factor because the remainder is 0.